Okay. So if you're just joining us from wherever it is you are, we're on page, what page are we on? Page 9 of the Topic 18 booklet, and there's a list there of things that we know about ammonia, which I'll put there, and we're thinking about ammonia as amines as a substituted ammonia. Okay. So let's just look down the group and things that we know already. So ammonia can hydrogen bond. Well, yeah, amines are going to be able to do that as well because we've got an NH group in the ammonia, unless I pull off all the hydrogens and replace them with something else. But as long as we've got that NH there, we're going to get a hydrogen bond. Trigonal pyramidal, yeah, still going to have a 107-degree bond angle there. That hasn't changed. Is it going to act as a nucleophile? Well, definitely. We've still got a lone pair of electrons there, which can be donated. Still acts as a ligand as well, because again, these are ammonia is acting with its lone pair in a coordinate covalent bond, so we can still do that. Does anyone remember the amine that's used in ligand exchange? You come to that yet? No idea? If you don't know, you just might not have done it yet. There's one which is, actually you've got two amines on either end of what used to be called an ethylene group. So that used to be called ethylene diamine. It would now be called 1,2-diaminoethane. And it's significant because it's got two nitrogens with two lone pairs at either end. So it has sort of 2 bytes of the transition metal ion. 2 bytes translates as 2 bytes. It's a nice word. You can almost hear the word biting as you say it. Bidentate, yeah. Dentate, as in dentist, as in place where you go to have your bite looked at. Yeah. So bidentate means it's kind of clamping down on the molecule like teeth on a bit of food. All right. So yeah, there we go. Amines are going to be bases. Yes, they are. All amines are weak bases. That's true, and they can accept a proton. We'll see that. And simple amines, at any rate, are soluble. As we start piling on alkyl groups, and if the alkyl groups are particularly big, then that will affect the solubility a lot, because of course alkyl groups are not soluble in water. Think about petrol, butane, these are not soluble molecules, but if it's a simple amine like this one, it'll be very soluble in water. Okay. So amines equal substituted ammonia. Right, let's do some naming. And we're going to give you 2 systems of naming, which might sound a little bit intimidating. Oh my God, I've got to keep track of 2 systems of naming. The reason there are 2 systems for naming amines is because it makes it easier. You can choose whichever system is easiest for you. I'll explain a little bit more as we go along. Okay. If I just pop, what have we got here? An ethyl group on an amine, or an amine on ethane, depends which way you think about it. I could say, okay, that's an ethyl group, so it must be ethyl amine. So the functional group is amine. Or I could say that's an amino group on an ethane and call it amino ethane. They're both perfectly acceptable ways of naming that molecule. The second naming system, that's more like naming halogens, right? If you're naming a molecule with chlorine in it or bromine in it, it would be chloropropane or bromobutane. So we're naming the amino group as just another group sticking off the carbon chain, amino. So we could have a long carbon chain. We could have an amine group there, and a chlorine group there, and a bromine group there. Fill in the rest of the hydrogens. What would that be called? Alphabetical. A, B, C. 2 amino. 4 bromo. 1 chloro. Butane. So, in a way, that's a familiar system, but it's not always very convenient. And when it becomes less convenient is when I start adding more ethyl groups to my amine. So here we only have 1 ethyl group. Now we've got 2 ethyl groups stuck to the same nitrogen. It's a bit less obvious what I would call this molecule using this system. But let's just try this system first. Would anyone like to just take a wild guess? You were going to say what? Diethylamine, that's pretty intuitive, isn't it? Because we've got 2 ethyl groups on the amine. Let's go one further. Let's stick a third one in. Yeah, so we can have 3 there. If we've got 3 hydrogens to remove, then we can put in 3 alkyl groups, and that would be triethylamine. Okay, that's pretty intuitive. How would I name this molecule using the other kind of system? It's not quite so easy. Anyone like to take a shot? Go on. But I'm starting off with, I'm starting off with aminoethane, and then I'm adding another ethyl group to it. So diethylamine is a perfectly good name, but we can name it using the other system as well. Okay, we just need to say where the other ethyl group is. So how would we say that in the name? N-ethyl amino ethane. What about the last one? Go on. N-diethyl amino ethane. Now, I don't know about you, but I find triethylamine a bit easier. So when you're looking at a molecule, you're making a decision about which name system is easier. Sometimes the decision will be made for you. If I have that molecule, for example, and doesn't have a sort of the first naming system kind of name, and the reason for that is that the carboxylic acid group is a higher priority than the amine. So, what would I call that? Using this name system. Well, it is an amino acid, yes, very good. And we'll study amino acids in their own right in a later topic. And of course, if anyone's done a bit of biology, you'll know amino acids well. That's the name that biologists often give that is glycine, but we need to give it its systematic name. Go on. aminoethanoic acid. So in this case, as I said, the decision's kind of made for us because carboxylic acid has a higher priority. We've seen that before as well. Remember when we have like a hydroxy group and then a nitrile? We've seen that sort of molecule before. What do we call that? Just before we finish for lunch. So we notice it's got an alcohol group in it, but because there's a CN as well, the alcohol gets kind of bumped to just being a side chain group. So it's not an alcohol, it's a hydroxy group. Anyone fill in the rest? So we can all go to lunch. No, but it's not propanol, that's the thing. That group is, it's not an amine, CN, it's not an amine group, it's a carbon triple bond, and yeah, nitrile. So what's the whole thing? Go on. Just say that middle word again. Propane. That's right. I want to be able to hear that E. Don't forget the E. We'd need a number there because the hydroxy group could be on carbon 3. So we have seen this kind of naming system before, where the functional group is kind of a lower priority. Right. Good place to finish. There.